Hi, I'm Tim Tyler, and this is a rather technical video about machine forecasting. In other words, it's about automating the task of predicting the future. In my last video on this topic, I discussed the reasons for thinking that a forecasting agent might be an important stepping stone on the path towards creating general-purpose machine intelligence. In this video, I will look further into one of the topics I discussed there and consider what access to a powerful forecasting agent would allow you to achieve, and how close to general machine intelligence it would actually get you. Firstly, forecasting and stream compression are equivalent problems, and I've explained in more detail why that is elsewhere, but you should bear that in mind for the next minute or so. Many seem to think that access to a powerful real-time stream compression system would be equivalent to access to a powerful machine intelligence. For example, Matt Mahoney writes, "I argue that compressing or equivalently modelling natural language text is AI hard. Solving the compression problem is equivalent to solving hard natural language processing problems, such as speech recognition, optical character recognition, and language translation. I argue that ideal text compression, if it were possible, would be equivalent to passing the Turing test for artificial intelligence, proposed in 1950. Matt goes on to say, "In 2000, Hooter proved that finding the optimal behaviour of a rational agent is equivalent to compressing its observations." He then goes on to argue that a powerful text compression engine would allow machines to pass the Turing test if they were given a sufficiently large quantity of relevant training data. I agree that if a sufficiently powerful predictor watched enough Turing tests take place and was then given a partial transcript, then it would be able to do a convincing job of predicting which reply was most likely to come next. However, I'm not really convinced that advanced forecasting is equivalent to advanced machine intelligence. A powerful forecaster seems to be rather like an intelligent agent with some pieces missing. One way of representing a cybernetic diagram of an intelligent agent would be as a combination of a forecasting component, an evaluation function, and a tree pruning algorithm. And if you just have a forecasting component, then you can use that to predict the consequences of your possible actions. However, you would really need an evaluation function and a tree pruning algorithm to make full use of that ability. Simple tree pruning algorithms are available as off-the-shelf components, though in general tree pruning can be a non-trivial problem. However, the evaluation function is a substantial and non-trivial element, and you wouldn't normally find it supplied with the forecasting component. A powerful forecaster would be able to predict the behaviour of agents in its environment. If it watched some experts playing Go, it would model them in considerable detail in order to acquire the ability to predict their moves. Being able to do that would mean that such a forecaster would be a pretty smart machine. Such a forecaster would need to know at least something about tree pruning and evaluation functions if it was successfully able to model and predict the actions of other agents in its environment. However, modelling the evaluation functions of others isn't quite the same thing as having your own evaluation function. To see why, imagine for a moment that you had access to a black box containing a fairly powerful forecaster, and that you wanted to use it to obtain a program which was able to play the game of Go better than the best humans can. In practice, you can't just graft a tree pruning algorithm and the idea of winning games as an evaluation function onto a forecasting component. The resulting composite machine would spend its lifetime exploring the resulting search space of moves and might never get any positive rewards through winning games. Evaluation functions in Go are complex things. Deciding which evaluation function to use is a non-trivial part of the problem, and having a forecasting component doesn't obviously help terribly much with it. Perhaps it would be possible to trick the forecaster into thinking that a super-intelligent Go player already existed, and then get it to predict its moves. However, without actually seeing the actions of a super-intelligent Go player, the existence of such an agent might not be obvious to the forecaster. It might be relatively challenging to fool the forecaster into believing that such a creature actually existed. The forecaster might instead apply Occam's razor and decide that such an explanation was a needlessly complex way of interpreting the data, and conclude accurately that it is more likely that somebody was trying to fool it. Much the same kind of thing might happen if you try to get the forecaster to imagine printing out the source code for such an agent. If I was convinced that an intelligent machine Go player existed, then I would be hard-pressed to write down a reasonable guess at what their source code was. Even if you did trick a forecaster into counterfactually believing that such an expert Go-playing agent existed, it might not do a very good job of predicting either its actions or its source code, unless it was itself extremely powerful. Like humans, an agent might be most adept at creating lesser agents, and have problems creating its own intellectual peer. So, to me, prediction doesn't seem to be quite the same thing as advanced machine intelligence would be. However, it does seem likely that an advanced prediction engine would allow you to build creatures that imitated humans, if given sufficient training time. With enough human-like machines around, the rate of scientific and technical progress might well increase substantially. That would allow faster research and progress into the field of machine intelligence to take place, facilitating a gradual evolutionary bootstrapping process that would then lead to full superintelligence. Enjoy.